In this tutorial, we will learn how to calculate compa ratios and to visualize whether pay compression or even pay inversion might be an issue, and we'll do so in R. So make sure that you have RStudio open, as you can see here. The next thing we're going to do is open up a R script editor by going to File, New File, R script, and when you save this, this becomes an R script file. So the first thing I'm going to do is use the hashtag to note what it is that we're doing here. So we're talking about compa ratios and pay compression in R and how that we can estimate and evaluate each one of those. And so what is a compa ratio? Well, essentially what a compa ratio tells you is how well an employee or a group of employees are actually paid relative to the midpoint of their pay range or their pay grade. Now, it just requires simple arithmetic to estimate or calculate a compa ratio. And in this tutorial, though, I add in some other bells and whistles to show how to work with dates variables and things like that, just to give us some additional practice there, as well as how to actually visualize this using a scatter plot. So the first thing that we're going to want to do is to set our working directory. And our working directory is where our data are going to live, or where our data already live, and we need to tell R where that folder is. And so I'll use the setwd function from base R. The data files that we're going to be working with today, I've saved them into my H drive R workshop folder. And so I'm specifying that within the quotation marks here and clicking run. So I've set my working directory there, and this is where, again, those data files live that I'm about to read in a second. To set your working directory, you could also go to Session, Set Working Directory, and Choose Directory to manually search for it using dropdowns. Okay, the next step is to read in the data. And I'm going to use the reader package, which is part of the tidyverse universe of packages. And it's reader all lowercase, and there's no E between the D and the R there. So if you haven't already, make sure that you've installed the reader package. If you have installed it recently, or you don't need to update it, then go ahead and skip this step right here. You don't need to run the install.packages line right there, but you will need to use the library function and type the name of the reader package without quotation marks as a sole parenthetical argument in the library function here. So let's definitely run this line, the library function line there. And you can see blue text down here usually signals that things went all right. So now that we've accessed the reader package, we can access the function from it that we want to use, which is the read_CSV function. Now, we're going to read in two data files here. And so the first data file is going to include personal data. So let's create an object that we'll call personal data with a capital P and a capital D. And this is the object that we're going to assign our data frame values to. And so we use the left-handed arrow to indicate that we wish to assign values to this object that we're going to create here in our R environment. And we'll use the read_CSV function from the reader package. And as the sole parenthetical argument in quotation marks within the parentheses, note the name of the first data file we wish to read in, which is capital P, capital D, and then ADA. So P data for personal data, make sure you put the .csv file extension there, because this is a comma separated values file, and this is a function that reads in comma separated values formatted files. So let's go ahead and run that line there. And you should see down here that it gives you some background information about the types of data in your data frame object, personal data, that you've just read in. Let's click on the name of the data frame object, personal data, in our global environment here to take a peek at it. And so as you can see here, we've got employee ID, start date, some demographic variables here, and so forth. All we're really interested in this personal data file for today is going to be the start date. And so we'll revisit that a little bit later on. Now, the next step is let's read in the second data file. So let's copy this script here, this line here, and paste below so we can just do some quick adaptations to it. So let's name the second data file that we're going to read in compensation. Compensation data with a capital C and a capital D for data. And the name of the file is capital C for data, or capital C for compensation, and capital D for data. So cdata.csv. Okay, and so both of these should already be saved in that folder that we specified as being our working directory folder there. So let's run that line there. Let's click on the name of that data frame object in our global environment. and take a peek. So you'll see that for both of these files, we have the employee ID variable here, which is our unique identifier variable. This is actually going to be our key variable. We also, with the compensation data, we have a pay grade variable here. It's not really a variable, it's actually a constant. All of these employees are from pay grade C, whatever that means for this company. And then we have their base pay for 2018 and their variable pay. Okay, so what we need to do next is we want to actually merge these data frames. So this will give us nice practice to join these two data frames together. And so what we're going to do is let's join, I don't know, or merge, whatever you want to call it, the data frames. Okay, and I'm going to copy these two lines here that contain our install.packages and library functions and paste here because we're just going to do a quick adaptation. And instead of reader, we're going to install the dplyr package, which also happens to be from that tidyverse universe package. And then we'll replace reader in the library function here with dplyr. And note, dplyr is all lowercase. I've recently installed the dplyr package here, so don't need to reinstall it here, but I do need to access the package using the library function, which you will certainly need to do as well, but you may also need to install this package for the first time or update it if it's been months since you last updated it. Okay, so let's click run there. And you'll notice we get some information here. It's a little bit of a warning in terms of using the dplyr package. And what it's saying is that this package has some functions like the filter function, the lag function, that are the same names as from the base R package stats. So what this is saying is that it's going to focus, if you reference the filter function, it's going to think that you're referring to dplyr, which would be what we want here. And you'd have to do an extra step to specify if you want the filter function from stats, which we won't need. And the same thing goes here for these other base R functions here. So we can ignore that message. Okay, so the next thing that we're going to need to do is come up with a name for our merged data frame that we're going to create. Let's call it merged df with a capital DF and a capital M. Use the left-handed arrow to note that we want to assign this new merged data frame to this object merged df here. And we're going to use just the full underscore join function from the dplyr package, and this will do a full join where it'll retain all data. Any case that has data, it'll retain it in the new merged data frame. Okay, so the way that we can specify this is just type in, or let's just actually make this easier. Let's copy first the name of our first data frame, which is personal data. That's our first argument. Let's copy the name of our second data frame, which is compensation data. That's our second argument. And then our third argument, and we're separating each of these by a comma. Our third argument, I'm actually going to hit enter to go down to another line here, just because I'm running out of space here. And we need to specify the key or the linking variable here by using by equals, and in quotation marks, specify the name of that linking variable, which as you can see here is employee ID is the common variable for both of these. So this is how we're going to match cases across these two data frames. So it's employee ID with a capital E and a capital I and D for ID. So employee ID. And let's go ahead and run those lines there. And now we have a new data frame object called merge df. And as you can see, now we've successfully merged these two data frames. Okay, so now we're ready to calculate our compa-ratios. So we'll make a note, calculate compa-ratios here. So this is our next step here. But before we do that, we need to calculate our total pay. Now we don't need to, but in this case, it's an added practice. We could do the compa-ratio just based on base pay or just based on variable pay. Let's add these together to create what we'll call total pay, which you could think of as representing total compensation. I guess minus any benefits values. Okay, so the next thing that we're going to do is, in order to create this total pay variable, is let's specify the name of our new merged data frame object, which is merged df, and then $sign to say that we wish to attach a new variable to it. And let's come up with a name for our new variable, which is going to be total pay. Okay, and let's just note underscore 2018 to say this is total pay or total compensation for 2018 here. Okay, So we're creating this new variable and attaching it to this existing data frame, and we note that using the $ operator here. And we'll use the left-handed operator to assign the total pay vector of values to this new variable and attach it to our existing data frame here. And so to do so, we're just going to type in our merged df data frame, $, and then let's type in the base pay variable here, plus, again, merged df, $, add a little space there, and variable pay 2018. So all I'm doing is simple arithmetic here, saying add, for each case, add the base pay value for that person plus their variable pay. The sum of this is going to be assigned to a new variable that we're going to call total pay. So let's go ahead and run that line there, and let's take a peek at our merged data frame here. And so if we go all the way over to the right, you'll see now we have a total pay variable for 2018, and it's just for each row or each case, which in this case, each row represents a unique employee. It's their base pay, so this person $44,038 plus $12,729 equals $56,767 here, and so forth and so on as you go down the different cases. Now we're ready to actually create the compa-ratio variable. And so in order to do so, what we're going to do is create a new variable. We have to come up with a name for it. Let's call it merged. Well, the name of the data frame is merged df. And then $, what do we want to call it? Well, let's just arbitrarily call it compa-ratio. That's pretty creative there. And then we'll use the left-handed arrow here to note that we want to assign values that we're going to specify in a second to this new compa-ratio variable. And using the $, we're saying attach this new variable to our existing merged df data frame here. So how do we calculate the compa-ratio? Where this is where some simple arithmetic comes into play. So let's first do parentheses here so we can specify the first part of the formula here, which is going to be the name of our data frame, and then $, and then that total pay variable we just created. Okay, and we're going to divide that by the midpoint for the pay grade. So all of these employees here are from the same pay grade C, so we can apply the same pay grade value for them. And let's imagine that the midpoint of this pay grade is $55,000. Okay, it's $55,000. Okay, so this is just simple division here. Total, the pay divided by the pay midpoint here. Okay, so this is a constant here, the pay midpoint for everybody. And then we're going to do one extra step, because this will give us a proportion here. If we want to convert that proportion to a percentage, let's multiply it by 100. Okay, so go ahead and run that there. Now let's go back to our data frame object, take a peek. Okay, now we have this new variable here, and it is our compa-ratio variable. So these are all percentages. So a percentage of 100% means that the person would be paid exactly the same as the midpoint for their pay grade. So you can see that actually this person right here is just slightly over 100%. So they're paid slightly over the midpoint of the pay grade. If you see a value less than 100%, it means that they're paid less than the midpoint. And so you could sort and look through this and get an idea of how many people, what kind of dispersion we're looking at here. So it's pretty tightly clustered in this case, about no more than 3 or 4% below the midpoint and about 5 or 6% above. So this is pretty good. The idea is that we obviously don't want too much drift. We would not want a situation where everybody's above 100%, because that would mean that everybody's above the midpoint or what our pay policy is in terms of the midpoint for that particular pay grade. And likewise, we wouldn't want the opposite necessarily. So what is a good versus bad compa-ratio? Well, that really depends on the situation, and it depends on the organization. It depends on the external market and so forth. So there's tons of rules of thumb out there, some of which might say, oh, a score of 80 or lower or 120 or higher are going to be problematic, whereas some might be more conservative than that, might say it's 90 or lower, 110% or higher. It really depends on your organization, the industry, and so forth. Okay? All right, so we've created this important HR metric here, which is the compa-ratio. Now, what if we wanted to calculate the compa-ratio for the entire group or everybody within this pay grade here? Okay, in this case, in our data frame, we just have everybody's in a single pay grade. Now, if you had multiple pay grades, and then by extension, multiple midpoint values for those pay grades, and you wanted to do what I'm about to do, then you need to use probably a group by function, such as from the dplyr package. And if you want to learn more about that, check out the aggregating and segmenting data in R tutorial. In this case, because everybody's from the same pay grade, we can just calculate a simple mean here of their compa-ratios of this vector here to figure out what is the average compa-ratio. Okay, and so we'll use the mean function from base R and simply copy in the name of the data frame, $ followed by the name of the compa-ratio there. And let's type in na.rm equals true. We probably shouldn't have missing data, but just in case, it's good to get in the habit of this. This just says remove any NAs when calculating the mean, where NA and R represents missing. Let's click run. And so actually we're doing pretty good here. We're only slightly over 100% on average. So on average, we're paying around the midpoint for the pay grade. So that's pretty good there. All right. So the next thing that we're going to do is we're going to kick it up a notch, and we're going to look at pay compression and, maybe even inversion if we were to see it. And sometimes this is called salary compression, salary inversion. And the idea behind this is to see, how are we doing in terms of paying people according to whatever our pay policies are. And one way of looking at this is to look at your compa-ratios relative to tenure in the organization, where typically you would assume that people who have been working longer in the organization are earning more pay. But if you start to see that there's some clustering, or there's some kind of it's getting backed up in certain areas where new employees are coming in and making just less than the people who've been working there a substantially longer amount of time, well, then you might start running into pay compression. And if you run into a situation, which sometimes happens in universities, for instance, where new employees come in and actually make more than existing employees that have worked there for a number of years, and who may even hold a higher job rank than they do, or job level, that would be an example of pay or salary inversion. So in this case, we're going to use simple scatter plots to visualize this and see how well we're doing here. Okay, so what we're going to do first, though, is we need to create a tenure variable. I wasn't very nice when simulating these data. I don't give you a tenure variable. Instead, I give you a start date variable here. So how do we create a tenure variable? Well, this means we're going to have to actually work with dates in R. And dates are notoriously finicky to work with in R, but it's great to practice doing this. So let's create a tenure variable. Okay, and so how are we going to do that? Well, let's specify the name of our merged df data frame here, $. What do we want to name this new variable? Let's call it tenure with a capital T. Use the left-handed arrow so we can assign values to this tenure variable. Now, what we need to do is, because we just have the start date for people, we need to come up with some date in the future that we can subtract the start dates from to come up with a length of time, okay, which will represent the length of service, or in this case, what we're calling the tenure variable here. And so let's say that you can pick any cut time in the future that makes sense. In this case, let's say it's December 31st of 2018. So the first thing that we need to do here is use the function that's called as.Date, and it's date with a capital D. And we need to specify as a sole parenthetical argument, in quotation marks, that future date from which we're going to subtract the start date value. So that's 2018.12 or -12-31. Okay, so this right here is, we're saying this is a date here. So we're putting this in kind of conventional R date format there. So this is important that we have to do this so that R knows that this is actually a date. Okay, the next thing that we're going to do is we're going to say subtract. And from this future date, well, at this point it was in the future for these employees, December 12th or December 31st, 2018, we're going to subtract each person's start date values, okay, or their start date. And so the way that we'll do this, I'm actually going to hit return here and take this on to the next line. You don't necessarily need to do that, but here, make sure you have that subtraction sign, the minus sign there. I'm going to do the as.Date function again, okay, and then let's specify the name of the data frame, $. And where's that start date value come from? Well, it comes from the merged df data frame there. So here we use a $sign to note that. So that's our first argument here. The second argument is we need to say that this is, what is the format of this variable? And so we're going to say it's a traditional date format, which you specify exactly like this. So in the quotation marks here, percentage lowercase m / percentage lowercase d / percentage uppercase y. Okay, and so this is the format. So what we're doing within this subtraction that we're doing here is we're actually converting this start date values, because they might look like they are of type date here, variable of type date, but they're not. These are actually going to be read in as characters most likely. And if you went up previously in your script, you'd see that. Yeah. So you see the start date was read in as characters here. Okay, so not as a date. All right. So what this means is now we are saying subtract from this date the start dates for each person. Okay, and we're going to assign this to a new tenure variable. All right, so let's go ahead and run this. Let's take a peek at our data frame object. Oops. And go all the way over to tenure here. And so now you'll see we have a new tenure column or variable. And wow, what do these values actually represent? Well, these are days. So the default with working with date variables is that you're going to have days here. Okay. And so this is 2,142 days that this person has worked there so far, assuming that all these people currently work for the organization still. Okay. All right, so the next thing that we need to do is let's take a peek at using the class variable or the class function from base R. What type of variable, what type of data is actually contained within this tenure variable? So let's copy that right there. So we just copied merge df, the name of the data frame, $, the new tenure variable. We're putting it within the class function here, which will tell us what is the type of the data within this variable, or in other words, the variable type. Let's click run. Down in our console, we see it's of type diff time, so difference in time. Well, this isn't necessarily going to be easy to work with in that current format. So here's again a fun thing you need to do in working with dates is we are going to convert this new tenure variable to type numeric so that those days will be interpreted as integers or numeric values. Okay, so what we're going to do that is we're going to specify, let's just copy this from above. So we're just going to overwrite the existing tenure variable here and say that it belongs again to the merge df data frame, and using the $sign to note that. Use the left-handed arrow to note that we're assigning values to it. And all we're going to do is use the as.Numeric function from base R. This will convert this existing variable here from this data frame. So let's copy it, paste it within the parentheses there. So as the sole parenthetical argument here, we're saying convert the tenure variable from the merge df data frame to type numeric. And then this will just overwrite the existing tenure variable. So let's click run. Okay, you won't see anything different. It won't look different over here when you come to the tenure column or the tenure variable. But if we run, let's copy and paste the class function once more with the tenure variable again and click run. Now is of type numeric. So this now means that we can work with it more easily in other types of operations. So one thing you'll note though is that, I mean, you may be fine working with tenure in days, but often we like to work with it in months or years. And so let's go ahead and convert this. Let's create a new variable and we'll call it merged. It'll be from our merge df data frame, $, and let's call tenure underscore YRS with a capital Y. So we'll have a new tenure years variable. And then we'll use left-handed arrow here to assign the new values to it. And all we're going to do here is let's copy the name of the data frame and our tenure variable. So this represents days here of employment with the organization. And let's just do divided by. And you could do 365, or if you want to be more precise, you could do 365.25 to account for those leap years. But let's just keep it simple here and just do 365. It's a constant. It'll get as close, it's ballpark. Again, you could do this, it might be more precise here. And so let's go ahead and divide by 365, and this will create our new tenure variable in years. Okay, so now let's peek at our data frame object. Now we have a new column here that's tenure in years. And so now you can see 2,142 days comes out to be about 5.9 years, okay? All right, so now we are ready to plot and look at, using a scatter plot, the relationship between tenure in years and the compa-ratio of employees. And so we are going to, let's create a scatter plot. And we are going to use that install.packages function again. And as the sole parenthetical argument, we're going to use the less r function in quotation marks there. It's less r with a capital R. I've recently installed this, but you may need to install the less r package for the first time or to update it here. If so, go ahead and run this line. At the very least, run the library function line here with less r as the sole parenthetical argument without quotation marks. So I'll click run there. Okay. And we're going to use the scatter plot function. So that's scatter plot with a capital S and a capital P. And the way that we specify this in less r, I'm going to open up my window here so I don't get an error message, is put the name of the first variable. First variable is, let's copy that and paste, tenure in years. Second variable is going to be compa-ratio with a capital C and a capital R, which we created above. And then just specify the data equals and the name of the data frame from which those two variables come from, which is merge df. Okay? And so let's go ahead and click run here, create our scatter plot. Okay, so here we have a scatter plot. So on the x-axis, we have tenure in years, and then our compa-ratio. And so what you can see here is we don't see any real systematic upward trend or downward trend, at least from what I can see. And another thing that you'll notice too is that we do have this phenomenon where a lot of the people are clustered. People tended to be hired more recently, so they tend to have less tenure as opposed to more tenure, okay? So what this seems to be implying here is that the tenure variable in particular is likely not a normally distributed, okay? But what you can see is as tenure goes up, we don't seem to see any kind of systematic change with compa-ratio. In fact, this might actually be somewhat problematic if you think about it, because assuming that tenure is valued in this organization and that people with greater tenure are worth more to the organization due to institutional knowledge, skills, accumulation, and so forth, you'd probably hopefully want to see a linear association here of some kind, okay? And what you'll see is if you look here, you can actually see at the scatterplot function, apparently there is an association here between tenure in years and, it's actually the p-value, this is non-significant here, but so what we do see here is that we don't see a statistically significant correlation, but perhaps that's due to the fact that this is not a bivariate normal distribution here. And if you want to learn more about what that means, check out the simple linear regression in R tutorial. And this could be due to the fact that perhaps this tenure in years this tenure in years variable is not normally distributed. So let's actually plot just that tenure in years variable. Let's do a VBS plot. So we'll use the plot function with a capital P from less r. And let's just type in, let's copy the tenure underscore years function there, or a variable there. And then let's copy data equals merged. So it's from that merge df data frame there. And let's click run. Okay, so yeah, just as kind of you suspected, so here you can see this is a positively skewed distribution. We have some extreme potentially influential cases over here, but most people tend to be clustered in with regard to fewer years of tenure or length of service. And so this seems to suggest that we have a non-normal distribution here. And if we were to look at the skew here, well, actually the skew isn't too bad from that standpoint. So it's not too concerning here, but let's see what would happen, for instance, if we did a logarithmic transformation on the tenure plot. So this is all just kind of bonus here to show you how to work with some different types of transformations and so forth with these data. And so if we wanted to create a new variable that was a logarithmic transformation, the tenure in years, because sometimes when you do a logarithmic transformation, it'll help normalize the data in terms of from a normal distribution standpoint. And so let's do merge df $, and let's do tenure, years, and let's underscore log. So let's just note this is the log transformation. Use the left-handed arrow here, and then we can use the log function from base R. So log for logarithmic transformation, and let's just type in the name of the data frame, $, and tenure underscore years. So let's do a quick log transformation and create this new variable that we'll call this. Let's run that. Okay. As you can see, if you go to your data frame object, now we have tenure and years, the logarithmic transformation over there. So let's now copy this plot function from above where we created the VBS plot, and let's just copy in this new tenure underscore years underscore log variable and replace it with the original tenure underscore years variable. And let's run this new plot function. Okay, so as you can see, if you were to compare these, we've somewhat got a more normal distribution. If you take a look at the skew here, it improves slightly. So in general, we probably didn't need to do a logarithmic transformation here. The skew, at least from this metric standpoint, wasn't too bad. But let's see what happens when we rerun our scatter plot here. So let's copy, paste below. Okay, and so we're just going to replace the original tenure underscore variable in this with tenure underscore years underscore log, the logarithmic transformation. And let's go ahead and run that. Okay, so a little bit better. Now we have the log transformation and tenure years here on the x-axis, still the compa-ratio over here, where again the 100% means that people are paid right at the midpoint. And so you're seeing that we've kind of unclustered it here at the lower end of tenure, but now you're left with this, what does the log of tenure years actually mean? So this is one of the challenging things when you actually do a transformation like this, is how do you actually interpret this at the end of the day? Now let's take a look at our scatter plot output here. And what you'll notice is by normalizing or creating a normal or trying to get it closer to a normal distribution for that tenure underscore years underscore log variable, we now have a statistically significant correlation. So it's less than 0.05 here. And we see the correlation value is 0.266, which is about a medium-sized correlation. It's positive. So apparently there is somewhat of an upward trend here, which would signify, oh, that's good. I mean, at least people who are working there longer tend to have higher compa ratios. However, this is by no means a very stringent test. This is just a nice way of getting a lay of the land of what might be happening in your organization for particular jobs in a particular pay grade, for instance. Now, if we did see a negative trend, that would be probably pretty concerning here. Well, and it really depends on what your pay policy is in your organization, but tenure is a common thing that we look at with respect to the compa ratios. Okay, so this wraps up this tutorial on how to calculate compa ratios in R and how to look for pay compression and maybe even pay inversion using R, and specifically using scatter plots. Thank you very much.